What's up, mathematicians? Justin here, and welcome back to our unit on measurement. This will be lesson number 8 called An Introduction to Area. Now, up until this point, we've been focusing mostly on finding lengths, measuring lengths, which is just the first part of the length, area, and volume trifecta. Of course, we've also talked about angles, but lengths have been our main focus. Now, in this lesson, we are going to go up a dimension from length to talking about area. Now, in order to talk about length or to measure length, we need to have a unit. And the choice of that unit is really up to us. It's up to you. You can use whatever you want. Now, if we're using dot grid paper like this, we could just say that the unit is the distance from one dot to another dot. So that would be, like that distance right there. So that would be our unit, and it could represent anything, right? It could represent a mile, it could represent a light year, it could represent whatever. But once we get up to area, the unit is not going to work anymore. It's not going to cut it. The reason is this is one-dimensional. And in order to measure area, we need 2 dimensions. So instead of a unit, we're going to use a square unit. And again, with the dot grid paper, I might as well just set the square unit to be the distance or the space inside, these 4 dots if I connect all these dots with lines of 1 unit length. Okay, so obviously it's not a perfect drawing, but you get the idea. I've just taken 4 dots like this as the 4 corners of my square unit. Okay, and so there we go. That is a square unit. So this is the basis of my area measurement. If I wanted to know how long a line was, so now in order to determine how long this line is, I can just count the number of units that make up this line. And so that goes to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I can just count and see that, okay, this line here is 11 units long. But with area, of course, I need to count the number of square units, right? Because this, technically this line has an area of 0. If it's one-dimensional, it has no area at all. It just has a length. So I'm just going to freehand draw a little region. So that's some region. And in order to figure out the area, the number of square units that this region takes up, I can just count how many square units. And it might help it by drawing them out like this. So I'll go ahead and do that real quickly. So what's the area of this? Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I didn't even plan that out, but this ended up being also 11. But in this case, it's 11 units squared. Okay, so that space right there. Now, of course, I'm just giving examples with whole numbers. You can have fractions of square units. You can have fractions of units. But we're not going to talk about that at this point. Now, how can we use these square units to come up with formulas, ways of determining the areas of some other shapes? Okay, so the first one we'll look at is the area of a rectangle. And I'm sure you already know what this is, but just to make sure we're making the point of connecting it to our idea of square units, let's just talk about it for a moment. So if we look at a rectangle here, we can see that we are able to count the height or the length of the rectangle. We're also able to count or measure, right? If this was not a whole number, we could, take a ruler and measure our units. But we can measure the length, we can measure this length. And in this case, this length is 3 and this length is 5. Okay, so what is the relationship between these 2 numbers and the area of this rectangle? Well, I'm sure you know this already, but all you need to do is multiply these two numbers. And in order to see that, you could imagine, okay, let's just make a grid like this. And we can see, oh, well, I have 3 squares in each column, and I have 5 columns. So 3 times 5 gives me 15. Or you could also say, I have 5 squares in each row, and I have 3 rows. So once again, 3 times 5 gives you 15. So the area of a rectangle, as I'm sure you know already, is area equals, we'll say, length times width. So length times width. And that formula ends up being very useful. It shows up all the time. But it is based on this idea of square units, right? Okay, so that's area of a rectangle. Now let's talk about the area of a triangle. And I'm going to show you an approach that seems to be what the ancient Egyptians used to determine how to find the area of a triangle. What they did is they said, let's start out by basically dropping a perpendicular from the vertex down to the base. Now there are a couple ways to do this. One is just to, get a square like this and line it up, and you could just draw a line right here, and that would, if this was a right angle, you would fold along this line. Well, yeah, that's the other option, right? It's just to fold along this line in such a way that the bottom edges match up with each other, and you come to a single point at the top. So here we go. Hopefully I'm getting these folds, doing a good job of these folds. That looks pretty good. Okay, but the key thing you need to do by folding or using this triangle is you need to get this point right here where the perpendicular from the vertex would hit the base. Then you need to take the vertex of the triangle, this point up here, and you need to fold it down so it hits this point right down here. Okay, so I'll go ahead and make that fold right there. Okay, so now I've got these 2 lines. I've got the line by making this fold, and I've got the line by making this fold. Okay, now keep in mind that if this height of the triangle goes from here to here, then this right here is half the height, and this right here is also half the height of the triangle. That is going to come in handy in just a moment. Okay, so I'll draw that line there. Now what I'm going to do is I'm going to cut this triangle right here at this line. Okay, so I've cut the triangle at this line. This line, by the way, is actually known as the median of the triangle. Now, I have one more cut to do, and I'm going to cut this top part of the triangle, which I've cut off from this part of the triangle, and I'm going to cut again along this line right here. Okay, so there it is. I've now cut my triangle into 3 different pieces, right? And so what the idea the Egyptians had is that if we take these pieces here and we take this piece right here and we slide it around, it will fit in right there. Then we take this piece here, we slide it around, it'll fit right there. And then we will end up with, you guessed it, a rectangle. So the Egyptian approach to measuring the area of a triangle is to turn the triangle into a rectangle. Now, the thing that we need to do is determine the height and the base of this rectangle, because that is what we need to determine the area of this rectangle. Now, if we reassemble this back into the original triangle, so we see this triangle here, we see that the base of the rectangle is the same as the base of the triangle, right? This distance between my 2 fingers right here. So that's the base of the triangle. Now, we also know that because I cut it in half in terms of this length right here, the height of the triangle, I cut at the halfway point, that the height of the rectangle is half of the height of the original triangle. Once I take these pieces right here, I slide them down to here, and I see, oh, wait a second. Okay, now I have a rectangle in which the base of this rectangle is the same as the base of the original triangle, but the height is half of the height of the original triangle. And so that's where we get the formula for the area of a triangle from. Okay, so here's my triangle. I know that this distance right here is the base, and then the distance, I'll go ahead and write it over here, but the distance from the top down to the base, that's the height of the triangle. And then I know that I cut it in half right here. Okay, so what is this distance right here? Well, of course it is 1/2 of the height of the triangle. And then we saw we could take this part, bring it down there, take this part, bring it over here. And after doing that, of course, we got a rectangle. I will draw in here. So here is the rectangle that I end up with after cutting, right? So let's see. Start with this triangle. I do those cuts. I slide these pieces down. I get this rectangle. And so that's this rectangle down here. I can kind of shade it in here so it's really clear what rectangle I'm talking about. And the area of that rectangle is the same as the area of that original triangle that I started with. So what that means is the area of the triangle, and you probably know this formula already, but I just want to make sure we talk through how you could sort of prove it, derive it for yourself. The area is 1/2 the height times the base. So this is fairly similar to the area of a rectangle, right? The area of a rectangle is length times width. You could also say base times height. And then the area of a triangle is half of the base times the height. So those are two key formulas for finding areas. Okay, now before I wrap up this video, I want to talk quickly about the area of one more shape, and that is the area of a parallelogram. I've drawn a parallelogram right here. Definition of a parallelogram is it's a quadrilateral four-sided polygon where both pairs of opposite sides are parallel. And the thing that we can do is we can just draw a diagonal through this parallelogram. So I'll just draw a diagonal right through like that. Okay, so once I do that, you can see very quickly, oh, that's made up of two triangles. And in a parallelogram, these opposite sides have the same length. And so whatever this length is here, we can call this the base. It's going to be the same as this length up here. Okay, so this is also the base. And then we can say, okay, well then let's find the height of this triangle right here. Okay, so that's the height. And then let's find the height of this triangle here. That's the height right there. Okay, and since these two lines are parallel, they must be the same distance apart in all points. So that means this height would have to be equal to that height. And so for this triangle here, you have base times height. For this triangle here, you have base times height. And so you just end up with two triangles that are actually equal to each other. So we could say, oh, the area of this triangle over here, I'll do this top one, okay? So that triangle, well, that's 1/2 base times height, based on the formula that you saw me just go through for the area of a triangle. And then how about this one over here? That triangle, also 1/2 base times height. Now, when I add these two together, 1/2 base times height plus 1/2 base times height, well, that's just going to equal base times height, right? So that's pretty simple in terms of verifying that the area of a parallelogram is just this. So the area of a parallelogram is the base times the height, okay? Now keep in mind, when we're talking about the height of a parallelogram, we are not talking about this length here, okay? This sort of slant height, we are talking about this perpendicular height, the height perpendicular to the base. Okay, so let's see, that'll wrap up this video. Quick introduction to area, not the lesson. We have more to do in the lesson, but I just want to show you how we can get some formulas for some of these basic shapes. So in the next video, we're actually going to revisit the measurement challenge about the fence maker, since now we have a tool that we can use to solve it. As always, thank you so much for watching. If you learned something today, please do like and subscribe, and I will see you in the next video. Bye-bye.